week 2, June 29th to July 5th, new 15 systems elimination using equations or having a problem that requires multiplication of one of the equations. Here we go. So we were looking at a system in the last video where you automatically, off the bat, everything was set up so that when you looked at your columns, X, Y, and the constant, you were ready to zero out one of your columns. You had opposite signs and matching numbers in either your X's or your Y's, which allowed you to solve for one of your variables off the bat, which is a really, really beautiful thing for you. And it's probably one of our favorite things to happen. What if that doesn't happen? Should be the question that you're asking, right? Because in math, that's usually the curveball. Because as soon as they teach you how to do something, they give you an example and they show you best case scenario. And the next thing that happens is worst case scenario, which is when that doesn't happen. So we're going to look at this one, number 1. We have this system. And if you look at it, it's really, really similar to the previous ones. You know, we draw our line underneath, we draw our river, and it has almost all the features that the other ones had. We can even highlight our columns here. We have our X's, we have our Y's, we have our numbers, our constants. And if you look, our X's aren't doing much to help us out. We have 2x and we have 5x. Which are not likely on their way to zero out. But our Y's, we have 1y and 1y. Our numbers are matching, which is what we need. But they're both positive. So our signs are also matching. We need our signs to be opposite. Okay? And what we need to do in order to get our signs to be opposite is we need to take 1 and we need to force it to be opposite. And the way we need to do this is we need to make one of them that's positive and we need to turn it into a negative. And the way we do this is if something is positive and we want to turn it into a negative, well, what's the only way we can take, something, we can change the sign of it without changing the value of it? Well, we multiply it by a negative. And the only number we can multiply something by without changing the value of it is by multiplying it by 1, right? So if we look at this, or if we take it out of the context of a problem, if I say I take 7 and I multiply it by 1, I still get 7. If I take 123 and I multiply it by 1, I still get 123. If I take 7.8 and I multiply it by 1, I still get 7.8. Now, follow me along. If I take 5 and I multiply it by -1, I get -5. If I take 1,324 and I multiply it by -1, I get -1,324. If I take 1/3 and I multiply it by -1, I get -1/3. If I take -7 and I multiply it by -1, I get +7. If I take -3.6 and I multiply it by negative 1, I get positive 3.6. If I take negative 1/4 and I multiply it by negative 1, I get positive 1/4. Okay? So the only way I do not change a value is by multiplying it by 1. The only way I change something from a positive or a negative to the other sign, to the opposite sign, is by multiplying it by negative 1. Okay? So now I'm going to erase this. So if you want to grab any of those examples, you can just back up the video. Okay? So I can either do this with the top or the bottom equation. It doesn't matter. But what I'm going to do, I'm going to do this strategically. I'm going to do it with the equation that tends to have smaller numbers. And the reason I'm going to do that is because if I do it with the one with smaller numbers, then I have more of a likelihood of keeping my numbers positive, right? If I do it with the one that has bigger numbers, then that's more likely to do it with my, that's more likely to move my numbers into negatives. Like here, if I do it here and I make the 23 negative, then negative 23 is going to pull my numbers into the negative world. Whereas if I make a negative 11, it's gonna stick to like 23 minus 11, that'll still be positive. Okay, if that makes sense. So either way is right, but again, I like to stay positive where I can. So the way I'm going to do this, the way I'm going to write this, if I multiply one thing by a negative, I have to multiply everything by a negative. So I'm going to multiply this whole equation, so I throw parentheses around the whole thing, by negative 1. Okay? And with the bottom equation, since I'm doing nothing with it, I'm going to throw that an arrow, so I'm just sliding it over. Okay? And I'm going to rewrite it. 5x plus y equals 23. Now over here, I'm going to distribute this negative 1 to this, and to this. And remember, all it's going to do is change my sign. So 2x becomes negative 2x. Positive y becomes negative y. And 11 becomes negative 11. Now again, why did I do this? Well, I'll show you. I'm going to redo my highlights. So this was red. This was blue. This was green. You see, this was why I did it. Because now, my y's, I still have one here and one here. So my numbers are still the same. But now I have a negative 1 and a positive 1. So those zero out and those cancel out. They didn't over here. They didn't cancel here. Okay, so they didn't zero out here. All right, so now they zero out. And now we're happy. And now I can continue on. So 5x minus 2x gets me 3x. 23 minus 11 gets me 12. You see what I mean? I'm still positive across the board there. If my bottom one was the one I had made negative, I would have had negative 3x and negative 12. I just don't like negatives. If I can avoid them, I do. I divide everything by 3, and I get x equals 4. Remember what I'm working towards, my ordered pair. So x is 4. Now, when I go to plug this x equals 4 back in, I'm still going to go to my original equations, okay? Because, again, I didn't mess with them, whatever. So I'm going to plug into the 2x plus y equals 11, my original first equation. And I'm going to get 2 times 4 plus y equals 11. 8 plus y equals 11. I've been substituting in now for 2 full weeks. I'm almost at the end of week 2 videos. So this, I should be flying through this. If you're not, that's okay, but this we've gotten so much practice with. This should be becoming like second nature. Okay, these zero out. I get y equals 3. That I'm plugging in up here. And I get 4, 3. All right, so let's see what happens now on number 2. So now you should start to kind of notice what's happening here, what you're seeing. I'm going to make this line longer because I know what's coming. All right. Highlights. Here's my red. Here's my blue. Here's my green. Here's my problem. Same sign, same number. I want same number, different sign. Okay? So, what do I need to do? First, find a pen. I need to make one of my signs opposite. So I'm going to take the first equation and I'm going to multiply it by -1. I'm going to rewrite my bottom equation because I'm not touching both of them, I'm just touching the one. So 5x minus 4y equals -22. My top equation, when I distribute all the way across, I get -3x, positive 4y, positive 18. Okay? Re-highlight. And what do I get? 2x, y's are gone, -4. Divide both sides by 2. X equals -2. Plug back in. Neither of these are really nice to plug in. I'm still going to plug into the top. Some people just have a habit of plugging into the top one no matter what. That it's just their routine. I always plug into the original. That's my habit. I got y equals 3. So my ordered pair is -2, 3. And I'm all done. On to the next page. All right, so now here, number 3. Looks a little bit different than number 1 and number 2 because although you have the same signs all the way across, like everything's positive in this one, you do not have the matching numbers that you've had in the other ones. Like in number 1 and number 2, I could say, okay, I have 4y and 4y. So I know that, I want to cancel out the y's or I want to zero out the y's. All I know is, or I know I need to change one of the signs. Here, I don't necessarily know what I want to zero out, or I don't know which ones I want to eliminate. So I have a little bit more to think about before I jump into this problem. I have to put a little bit more forethought into this. So when you do this, when you think about this, this is where all of that stuff from Math 10, that basic math theory, comes into play. Those factors, those multiples. Because if I think about the x's here, 2 and 3. If I think about 2, 4, 6, 8, 10, 12, and then I think about 3, 6, 9, 12, 15. Yes, there are some numbers in there that match up, okay? But I would have to do something to both of those equations to get one of those numbers to happen, right? And how do I know that? Well, because I had to make both of those lists to find one of those numbers, right? I had to list out both of those lists to find a common number. But now, if I think about the number 1 and 5, and you might be asking where I'm getting a 1 from, well, there's a 1 in front of that y. Can I turn a 1 into a 5 by multiplication? Can I turn 1 into any number by multiplication? Heck yes, I can. All right? I can turn the number 1 into any, I wish you could do that with money, right? I can turn the number 1 into any number I want by multiplication. And the way I do it is I just simply multiply 1 by that number. Okay? And then the beautiful thing is that I can also take care of the sign in the same step. Because here my problem is not only that the number doesn't match, but that the signs are also the same. Because remember, our two goals. I want opposite signs, same numbers. So, I do not have opposite signs, and I do not have the same numbers. So if I'm looking right here, okay, I'm going to take this equation and I'm going to multiply it by 5. And we know the trick for getting opposite signs is to multiply it by the negative. Now watch what that's going to do. This one I'm not going to touch. So I'm going to get 2x plus 5y equals 2. Okay. On the bottom, I'm going to get negative 15x minus 5y equals negative 15. Do you see what happened there? It's that middle piece that we really, really care about. And now do I have opposite signs, same numbers? Yes, I do. And that's what I need to happen. So now they cancel or zero out. And when I combine the rest, I get negative 13x equals negative 13. I divide both sides by negative 13 to get x alone, and I get x equals 1. Working towards that ordered pair, I get positive 1 for my x. And now I want to go back to my original equation. I'm actually going to plug it into the bottom one this time. So I get 3 times 1 plus y equals 3. That's 3 plus y equals 3. I subtract 3 from both sides, and I get y equals 0. 0 is an absolutely okay answer. You can have $0 in your pocket. So 0 can absolutely 100% be an answer. Because think about it, when you graph, 0 just means it's either on an axis, the x-axis, the y-axis, or the origin. So my ordered pair answer is 1, 0. All right, let's look at this one. Number 4. This is very similar. All right, we have a problem. Our problem is we do not have signs or numbers that line up or match up, but we do have this 1 that we can turn into any number we want. So let's turn the 1 into the 3. Okay, turning a 1 into a 3, I'm going to multiply this bottom equation by 3. And because we have these signs that match right now, that's a problem. In order to get these signs that match to not match, I'm going to throw the negative in front. Because I'm touching the bottom equation, because I'm manipulating it, I'm going to leave the top one alone in this one. So I have 5x minus 3y equals negative 8, which is going to make the bottom one negative 6x plus 3y equals negative 18. Again, looking at this, did we make happen what we wanted to happen? Yes, we did. Those zero out. I get negative x when I combine those. And I get negative 26 when I combine the constants. I'm going to divide by negative 1 to get my x back to being a positive. So x equals 26. Bigger answer than we're used to, but that's okay. It's still valid. And I'm also going to plug into the bottom one for this just because it's smaller, it's more positive. So I get 2 times 26 minus y equals 6. That gives me 52 minus y equals 6. I subtract 52 from both sides. I get negative y equals negative 46. Divide both sides by negative 1. Y equals 46. And I'm all done. Go ahead and practice. Let me know what you think.